plywood. It's kind of the unsung hero of our homes, our offices, our furniture, you name it. But what if I told you that the glue holding it all together has a hidden and, yeah, a potentially hazardous secret? Okay, let's dive into the fascinating scientific quest to reinvent one of our most common building materials.
Seriously, just take a quick look around you right now. I bet you're within arm's reach of some kind of engineered wood. But have you ever stopped to think about what's actually in it? You know, what makes it tick? The story is way more complex than you might imagine.
Plywood and other panels like it are honestly engineering marvels. They take all these different parts of a tree and turn them into boards with consistent, reliable properties. And that's the genius of it, right? It's incredibly efficient, it minimizes waste, and it gives us these strong, versatile materials for pretty much everything.
Now, the magic ingredient that makes all this possible is a synthetic glue called urea-formaldehyde resin, or just UF resin. For decades, this stuff has been the industry standard. And why is that? Well, because it just works. It's cheap, it forms an incredibly powerful bond, and it cures super fast, which is absolutely perfect for mass production. But, and this is a big but, there's a catch. That F in UF resin, it stands for formaldehyde. And as the International Agency for Research on Cancer pointed out way back in 2006, it's a known carcinogen. So the very glue that holds our world together can slowly release this chemical into the air we breathe.
And look, this isn't a new concern. Way back in the 70s, people started talking about sick building syndrome, all these health issues linked to indoor air quality. And one of the culprits they identified was materials that were slowly leaking formaldehyde. This discovery really kicked off a decades-long push for safer building materials and much stricter standards.
And that brings us right to the heart of our story, a classic scientific dilemma. You've got the strength of the glue on one side and the safety of our homes on the other.
So you're probably thinking, well, that sounds simple. Just use less of the bad stuff. And yeah, it's a totally logical thought. But as researchers found out pretty quickly, it is not that easy. Not at all. And this is where it gets really tricky. You're stuck in this fundamental trade-off. When you reduce the amount of formaldehyde, yes, you get lower emissions, which is fantastic for safety. But at the same time, you get a much weaker glue. And the resin itself becomes unstable and a lot harder to work with. For years, this just seemed like an impossible problem to solve. Okay, without getting too deep into a chemistry lesson here, this is basically the reaction. The formaldehyde molecules link up with the urea molecules, creating these long, tangled-up polymer chains. And that's what gives the glue its incredible strength. So you can see why messing with that recipe is such a delicate balancing act. And believe me, plenty of people have tried. Researchers developed formaldehyde-free alternatives, but they were often way too expensive, or they'd fall apart if they got wet. And other attempts to just lower the formaldehyde, they produced glues that just weren't strong enough to pass the basic commercial standards. The problem just stuck around. But a recent study decided to tackle this problem head-on. Not by trying to find brand new ingredients, but by completely remixing the classic recipe, using a modified multi-step process. Honestly, the best way to think about this is like baking a cake. The researchers focused on what's called the mole ratio of formaldehyde to urea. Let's just call it the F to U ratio. Their whole goal was to find that perfect new recipe that was strong, stable, and safe. So instead of just dumping everything in a pot at once, they use this really careful 4-stage process. They react it, they thicken it, they add a little more urea, and then they thicken it again. But the real genius is in that final step. After the main reaction is done, they add one last batch of urea. This acts like a scavenger that goes in and specifically mops up the leftover formaldehyde, all without weakening the glue. It's pretty clever. So, the big question, did it actually work? Well, the researchers tested a whole range of different F/U ratios, all the way from 1.5 down to 1.0, to see if they could nail that perfect balance, that sweet spot. All right, so this graph here confirms the first half of that dilemma we were talking about. See the bars on the right? They've got the highest F/U ratio, and they show the strongest bond. As you move to the left and that ratio gets lower, you can see the strength just steadily drops. So yeah, less formaldehyde really does mean weaker glue. No big surprise there. But now, look at this. Here's the other half of the equation, and this is what's so brilliant. This graph shows that as that F/U ratio went down, the formaldehyde emissions from the final piece of plywood absolutely plummeted.
I mean, the conclusion is just undeniable. A lower ratio in the recipe means much, much safer air in your home.
So where did these two lines cross? Where was that sweet spot that gave them enough strength, but with way lower emissions? The magic number they landed on was a final FTU mole ratio of 1.1.
Let's put that number into perspective, because this is where it gets really good. At a ratio of 1.1, the bonding strength was 0.925 megapascals. That's comfortably above the commercial minimum of 0.7. Okay, so it's strong enough. Now, the emissions down to around 2 milligrams per liter. I mean, that's more than a 90% reduction compared to some standard resins, all while staying strong enough for everyday use. That's a huge win.
But here's the final piece of the puzzle, the part that makes this a real-world solution and not just a lab experiment. This graph shows the resin's viscosity, basically its thickness, over time. It stays stable and totally usable for more than 3 weeks. And that is critical, because it means a factory can mix up a huge batch and not have to worry about it going bad before they can use it.
So, what does all this mean for the future? Have we finally solved the plywood problem once and for all?
This research is, without a doubt, a huge step in the right direction. It proves that we can create a strong, stable, and practical plywood glue with dramatically lower emissions. But it's not the final chapter. Emitting around 2 milligrams per liter is a massive improvement. But the world's strictest standards, like the ones in Japan, for example, require emissions to be below 0.24. So there's still a little ways to go. And scientists are already on it. The next frontiers are things like adding new scavenger chemicals right into the glue, developing special coatings to trap any leftover emissions from the finished board, and, of course, continuing to fine-tune the resin formula itself.
You know, this whole journey started just by questioning a hidden ingredient in something we literally see every single day. It kind of makes you wonder, doesn't it? What other common materials out there are just waiting for their own scientific breakthrough to be completely reimagined for a safer, healthier future?